and I'm a research associate at Imperial College London. I'm also the chair of the network as well as the chair for the session today. So today the network is very happy to be able to present Dr. Alex Stern from the US Environmental Protection Agency, who'll be giving a talk on the work she's been doing to assess the environmental impacts of US school lunch programs. Before I hand over to Alex, just a few quick words on housekeeping as well as a little bit of information on the network itself. So today's session is being recorded, so please mute your microphones as well as switch off your camera so that we can save bandwidth. The recording as well as a copy of the slides will be made available after the presentation, and you will be notified by email when these are made available. For any reason, if you require subtitles, these are available in Teams. So at the top of your window, you should see an icon that has 3 small dots. If you click on that, you'll find the option to enable subtitles and live captioning. There will be an opportunity for Q&A at the end of the session. So if you do have any questions, please type these in the chat. And so now a little bit about the network itself. So the Imperial Lifecycle Network is a network based at Imperial, which aims to bring together and connect lifecycle related research and researchers at Imperial, as well as the wider lifecycle community. The purpose of the network is to foster collaborations and facilitate networking, as well as to share knowledge and contribute towards advancements within the lifecycle field. For further information on the network, visit our website. You can follow us on Twitter, and for any UK-based lifecycle practitioners, consider joining the Lifecycle Community UK group on LinkedIn. So today's seminar is the 8th in the seminar series that we've been hosting since 2020. And recordings and all presentations presented in these are available on our website. In addition to these, we also have 4 future seminars planned in a diary. These will be in September, October, November, and January. So please check out our website or follow us on Twitter to be notified of when registration for these becomes available for registration. Topics of our future and upcoming seminars include prospective LCA, nutrition in LCA, and bioplastics. The next presentation after this will be on September 27th, and we're hoping to have the event page for that go live beginning of next week. So moving on to today's speaker. So today, the network is very happy to be able to present Dr. Alex Stern from the US Environmental Protection Agency. He'll be giving her talk titled Environmental Impacts of the US National School Lunch Program. So Dr. Stern is a fellow at the US Environmental Protection Agency, Office of Research and Development. She recently completed a PhD at Tufts University, Friedman School of Nutrition, Science and Policy, in agriculture, food and environment, where her research focused on assessing the environmental outcomes of federal food policy implementation. At EPA, she'll be working on quantifying the environmental impacts of food waste and determining the benefits of different waste management pathways and opportunities for source reduction. Her research interests include life cycle assessment, food system modeling, and behavioral interventions. Prior to completing a PhD, Alex worked as a community advocate in Washington, D.C., supporting food access, nutrition, and food waste recovery programs with D.C. Central Kitchen. And with that, Alex, I will hand over to you and I will stop screen sharing.
Thanks so much, Jasmine. Okay, so I'm gonna go ahead and share my screen. Actually, before I do, let me put it in presentation mode and then I'll share. Oh, nope, I can't do that. I have to share first. Okay, here we go. Give me a second. So
Yeah, we can see that.
In presentation mode. So can everyone see just the very first slide and not my notes?
Yes.
Awesome. And I'm looking at the camera?
Yes, you are.
Okay,
You're looking
awesome.
at this.
Thank you. Thank you so much. As Jasmine mentioned, today I'll be discussing my research on the environmental impacts of the National School Lunch Program in the U.S. Thank you so much for that introduction, Jasmine. I'm just going to add a little bit on. As you mentioned, I'm a postdoctoral fellow currently at the EPA. I am focusing on food waste research, evaluating the environmental impacts of food waste, but also thinking about interventions to prevent food waste in households and how those interventions might reduce the environmental impacts of food waste. But before all of this food waste work and related to this work, I was at Tufts University, which is in Boston, Massachusetts, and I focused my research on healthy diets from sustainable food systems. And a lot of my ideas for my research at Tufts actually came from work that I had done in DC previously. I worked for a nonprofit in the food system, working with communities to get nutritious and healthy food into schools and all across DC. And then prior to that, I received my Master's of Public Health from Emory University, it's in Atlanta, Georgia. Just a few disclosures. This research was funded by USDA and is actually not associated with the work that I'm doing at the US Environmental Protection Agency. So let's go ahead and dive right in. I think we all know on this call as LCA practitioners that it's well established that the food system is driving climate change and environmental degradation. And it's also contributing to unprecedented levels of malnutrition and economic inequalities. So research has really sought to address these issues and determined that there's a critical step in addressing these issues, and it's dietary change, or as listed here, food demand management. And they've determined that essentially we need to start shifting dietary patterns, and this is an essential part of creating a sustainable food future. So the UN FAO has been principle and defining this this concept of sustainable healthy diets and showing exactly what the shift would look like for communities to start making this transition. They've laid out a definition that's shown here in bullets. And I just want to point out that a key part of this definition is that diets should be sourced and produced in environmentally sustainable ways that don't contribute to climate change and protect biodiversity. So the UN has gone about establishing this definition, and there's been a lot of research helping to design sustainable diets. And this research has really been done at global and national levels to determine that this is a key step to ensuring a sustainable food future. But what's missing is this work done at a much more localized level. So diet is tied to our culture, our heritage, our skills, our community. So really, it's important that the next steps of this work really start to define sustainable diets for specific communities so that we can start performing interventions and actually seeing this transition globally. So that brings me to a really unique community. This is children in the US as they're eating lunch. This was particularly a unique community because in the US, about 40% of children, nearly half of children, are receiving lunch through a federal program. So the US federal government provides schools with monetary support, surplus foods, and nutrition standards for meals in schools. They spend about $14 billion every year. And this allows children to receive meals at low cost or free. Actually, in 2019, about 1 in 5 students received their lunches completely for free. And due to COVID, this has actually increased substantially. So this is a really important program. It's called the National School Lunch Program. I'll refer to it a few times throughout the presentation as the NSLP. And it's a really important program and a really great opportunity to support dietary change because it has a large breadth reaching millions of children, a large budget, and it's also reaching children as they're defining their habits for the future. So this brings me to my research objectives. So the overall objectives of this research were to evaluate the sustainability, specifically the environmental impacts of lunches served through the NSLP, the National School Lunch Program, and then also use this information to create realistic alternative menus, sustainable menus for schools to implement. Now today I'm just going to be speaking about that first phase, evaluating the sustainability, because that was a whole research question in its own. The creating realistic alternative menus, that's something that I'm hoping to come out with papers hopefully within the next year, and we can talk about that at the end. If you're interested in that, I have published some of that work in my dissertation, but it's not available yet in journals. But today, again, I'll just be talking about assessing the environmental impacts of lunches served in the National School Lunch Program. So to do this, I needed life cycle inventory data relevant for the National School Lunch Program. And then I needed to estimate the environmental impacts of lunches from their agricultural production. And then with those environmental impacts, looked at the distribution of impacts, looking at the highest impact lunches, the lowest impact lunches, and the composition of those lunches in order to inform policy and make recommendations. So I'm actually going to spend a while, a good portion of this presentation on methods. I think as LCA practitioners, we always hope that we can get a little bit more of this. And specifically, I want to really show how I linked complex foods to agricultural commodities and life cycle inventories. So for this research, I needed 4 main categories of data. I needed data on school lunch, so what is actually being served in the US in this program. Then I needed recipe data, so essentially data that could take complex foods like pizza and burritos and break it down into agricultural commodities. I needed environmental data or life cycle inventories, and then I needed conversion data because all of the information for lunch data was for food served, and a lot of environmental data is for whole commodities with bones and shells and stems. So for the school lunch data, I was really lucky. There's an excellent data source called the School Nutrition and Meal Cost Study. This is USDA, our U.S. Department of Agriculture's periodic assessment of the meals program. As I mentioned, the federal government spends about $14 billion a year on the school meals program. So USDA administers this program and also does this study to evaluate how the program is running, and they look at all sorts of things, including what is being served. So they do this through a nationally representative sample of schools. And in their most recent study, they covered about 2 million lunches that included over 1,000 unique food items. And the way that they do this is just a web survey of school nutrition managers, the people that are planning the menus. And then the data is sent back to the federal government and to researchers to be analyzed. And when they do that, they do this really great step where they uniquely identify all of the foods that nutrition managers are saying are being served. And this is a really important step I want to call out because it really supported my research. They uniquely identify each food with a food and nutrient database for dietary studies code. It's a mouthful. I'll refer to it as FNDDS. You'll see it in the next few slides. But this was a really important step to be able to link this lunch data with other data sources. So here's some example of some of the lunches that are served in the National School Lunch Program. Really quickly, I just want to explain the National School Lunch Program has some requirements that schools must meet in order to receive federal reimbursement. So they'll have things like calorie targets and sodium targets. And one of the main ones is that schools have to provide students with 5 meal components: a meat or meat alternative, a grain, a milk, a fruit, and a vegetable. Some schools allow students to select all 5 or at least 3 of those items. So lunches can look really different based on students. Some students can choose just to take 3 items as long as one of those items is a fruit or veg, and choose something like a peanut butter and jelly, apples and carrots, versus another student might have all 5 components where one is beef and a milk. So there's a wide range of lunches. So once I had selected my lunch data had all of this information on what was served, I needed to break that down into agricultural commodities. Like I mentioned, there were complex foods like pizza, but I needed to take that down to tomato, wheat, milk. So there's something called the Food Commodities Intake Database. This is also a government database in the US. And what it does is it identifies over 500 unique commodities and links it to thousands of foods that are consumed in the US through that Food and Nutrient Database for Dietary Studies FNDDS code. So the fact that USDA researchers aligned all of the menu items with these foods allowed me to connect to this other database, which was my recipe database. And I want to point out this new paper that just came out. So when I did my analysis, the food commodities intake database, this recipe database, only connected to food and nutrient database for dietary studies codes up to 2010. But this new paper just came out by a colleague of mine, Zach Conrad, that actually connects these databases up until I think they're at 2014. So this is a huge step in using these databases. So here's kind of what this looks like. On the left-hand side, let me use my pointer. Yeah, on the left-hand side here, we see the food and nutrient database for dietary studies. So these are those complex foods. And this is the recipe, the FCID recipe for whole wheat bread. So within whole wheat bread, which you might see on a menu, you have all of these different commodities in these proportions. So you have soybean oil, you have milk fat, and then the recipe files also contain information on if the commodity is cooked or processed. So once I had my recipes, I needed to determine how I was going to evaluate the environmental impacts. And I'd love to have a discussion about this at the end. I thought this was one of the most challenging parts of my research, was just starting off. There's so many different options for looking at environmental impact data and just kind of comparing and contrasting them, looking at the pros and cons of using different sources. So I have a list here of all the different options that I was considering. And there really were pros and cons. Like, for example, with World Food LCA database, this is a proprietary database, but they had really great life cycle inventories and results for US poultry production and beef production. Whereas with EcoInvent, these inventories existed, but not with US production, not with US geography, only for a global process. So ultimately, I chose to go with EcoInvent version 3.6. I made this choice for many reasons, but one of the big reasons was this was actually the only life cycle inventory that I had available to me. All the other data that I had listed on the previous slide was only available to me in the results form, and I wanted the ability to really go into the inventories, potentially manipulate them if I needed to, and then also use consistent impact assessment methods and run uncertainty analyses. So EcoInvent in the end was the best option, and is what I used for all of my results. So EcoInvent is a huge database with tons of, you can call them processes, activities, or inventories. And I had to go about and select which ones that I wanted to use to represent the commodities in the food commodities intake database. So I did this by developing a hierarchical decision tree with the first level of my choice starting at function. So it was really important to me to find life cycle inventory data that represented the exact function that I needed. So if I needed to model a tomato, the process should be specifically tomato production. Where that wasn't available, when an exact product wasn't available, I would use a similar product or a proxy. For example, we'll look at this in the next few slides, but for something like grapefruit, I would use the average impacts of other citrus fruits. The next level on my hierarchy was geography. It was really important that I was selecting processes from the US or common importing countries. When these were not available, I relied on regions with similar climate or a global process. Finally, some of the last considerations I had were just allocation, system boundaries, functional units. This was all actually really easy to manage because I had chosen eco-invent, which is very consistent in a lot of these parameters. So here are some quick examples of some of the processes that I selected. So on the left, we'll see these commodity numbers and the commodity descriptions. The commodity descriptions would list things like apple with peel or if it was a peeled fruit. So that's why there were so many of them. And I selected almost an exact process of apple production in the US. As you can see, this is not a proxy. But some of the ones below here, I had to use proxies for the vegetable collards. So there was no process in eco-invent that represented collards production. So I created a proxy group for brassica, which averaged the impacts of broccoli, cabbage, and cauliflower production. And you can see again the citrus example, the grapefruit and the citrus group. So once I had selected all of my processes, I had to actually run my analyses. I ran these in OpenLCA, and I started using ILCD, but ran into some issues with these impact assessment methods in OpenLCA using eco-invent 3.6, so happy to talk about that as well. I ended up switching to using recipe because most of my issues were related to the water resource depletion impact category. So recipe just has a water use, and that ended up making a lot more sense and working. There were just some flow mapping issues. And then I used OpenLCA, but I was really lucky that I had some colleagues that could compare some of the results that I was looking at using SEMA Pro. So I had initially wanted to run uncertainty analyses using Monte Carlo. That did not necessarily work out. Happy to talk about that adventure as well at the end. So I ended up doing uncertainty analyses by comparing different databases, software, and impact assessment methods. And this kind of lists it out, all the different databases, software, impact assessment methods that I looked at. And I'll talk about this more in the results and how this came out. So back to thinking about linking everything together. So I had these menu items and their recipes and also this impact data. So how did I link it all together? Well, I started with a menu item. For example, there was a fruit cup on the menu. Then with the FCID recipes, it would break it down into commodities. So something like pear, apple, corn syrup. Then I had linked all of these commodities to process or LCI data in eco-invent or proxy groups like tree fruit. And then after linking them, I ran the impact assessment and multiplied that by the proportion that a commodity existed within a recipe, and then multiplied that by any conversion factors, removing seeds or stems, etc. And then I summed across that to get the final impact per 100 grams of each menu item. And that was for, again, about 1,300 unique menu items. So with the impacts of each menu item, I was able to evaluate the impacts of lunches and lunches on average. Moving on to my results. So my results were pretty consistent with previous research, nothing really red flagged. Animal products were drivers of environmental impacts, and the lowest impact lunches had less animal products and the higher impact lunches had more animal products. So pretty consistent. This first table that we're looking at is showing the mean environmental impacts per lunch and then per 1,000 kilocalories of lunch. So here we're seeing in this kind of goldish yellow box that per lunch, each lunch produces in its production about 1.5 kilograms of CO2 equivalent. Now this number is pretty important because it helps schools understand where their lunches are falling. Are they kind of higher than the mean, below the mean? and gives schools a baseline to start with as they're trying to develop menus that have lower impacts or serve lunches that have lower impacts. Compared to other literature, this was kind of difficult actually. I tried to make comparisons of 1,000 kilocalories of lunch, the global warming potential of lunches to something like the American diet, but because of the composition, like the amount of protein or dairy, etc., this made comparisons really difficult. And also just the modeling, because people model in such different ways, different allocation methods, different impact assessment methods, different units, it made comparisons really difficult. But I can say in general that these results fell within the realm of what others are reporting. Okay, so let's move on. After looking at the mean impacts, I wanted to look at the lunches, the composition of lunches that had the lowest impact and the highest impact. So those lunches that had impacts far above the mean or far below the mean, and specifically looking at lunches that were in the first quintile or the 20th percentile. Those are the low impact lunches for all impact categories, and lunches that fell in the 80th percentile and above for the high impact lunches. So this table is showing us on the left food groups. So these are all the things that a lunch can consist of. Then these two columns in the middle are the amounts, so the cup equivalents or the ounce equivalents on average in low or high impact lunches. This p-value is saying if they are significantly different. So some of the main findings, the main differences between these lunches were that high impact lunches had significantly higher fruit juice. They also had higher vegetables, specifically starchy vegetables. And they also had significantly higher protein foods, such as beef and pork and poultry. This next slide is actually just a continuation of the previous table. I couldn't fit it all, so again, just the food groups on the side. And just continuing the results. So here we see that low impact lunches actually had significantly higher seafood, nuts and seeds, cheese, and whole grains. So it's actually pretty interesting, this cheese finding. Some would expect, because this is an animal product, that we would find cheese higher in the high impact lunches. But for the National School Lunch Program in the US, this actually kind of makes sense, because lunches that don't contain meat almost always have cheese. So any vegetarian option is really normally a cheese option. So in summary, high impact lunches offered more meat, fruit juice, and starchy vegetables, and low impact lunches had more seafood, nuts and seed, cheese, and whole grains. So we were just looking at the composition of high impact lunches and low impact lunches. This table is going to show us the contribution of food groups to total impact. So looking at the total greenhouse gas emissions of all the lunches, what was driving that impact? So again, we have our food groups on the left here, and in the columns here, we have each of the impact categories that I looked at. And red is denoting higher numbers, and green is denoting lower numbers. Lower percent contribution to impacts. So right away, our eyes drawn right to the middle of the red line, because meat is driving impacts. It is a greater proportion of impacts than pretty much all other food groups. And this is really interesting, because if you look at this column right here, the percent of lunch by mass, meat only accounted for about 8% by mass of the lunches, but was contributing to 70% of the global warming potential and the land use, and high percentages of the other impact categories as well. So following meat, the next driver was dairy. dairy was driving, again, global warming potential and land use, marine eutrophication potential, etc. I want to draw our attention though to this water column. So water kind of stood out. A lot of the red had focused around the meat and dairy, but with the water consumption, you'll notice that we're seeing red in fruits and vegetables. So that fruits and vegetables were contributing a larger share to the water consumption impacts. But I want to note here, which is kind of interesting, even though fruits are contributing about 27% of the water consumption of the whole lunches, they represent about 20% of the lunch by mass. So it's not a huge difference here. Same for vegetables as well. Finally, I want to point out these numbers all in green at the very bottom. So seafood, nuts, and seeds really weren't served that often. They're a really small proportion of all the lunches by mass and therefore really weren't contributing a lot to the environmental impacts. Okay, so I want to talk a little bit about my proxy groups and the assumptions. So I mentioned that I used EcoInvent and I needed to choose processes or life cycle inventories from EcoInvent to map to all of the commodities in FCID to connect to the recipes to the foods. So this table is showing the proxies, the number of proxies that I used and their percent contribution to impacts. So on the left here, I divided them by food groups. Here are the number of commodities in each of the food groups. So there were over 500 commodities in this database. And you'll actually see, if we look at this bottom total diet, for the percent of the commodities requiring proxies, over half of the commodities in this database required proxies, which seems crazy. It's like, that's a lot of proxies. But I will point out that the commodities in this database, some of them are really unlikely to be eaten in schools. And actually, just looking at the 10 most common commodities found in school lunches, that represented 65% of the mass of lunches. So there really were a lot of the commodities in this list that didn't show up in lunches. So we see that even though 54% of the commodities were represented by proxies, these proxies didn't really have a large impact on the environmental impact. So barely 3%, not even 3% for global warming potential and land use, and the highest one was just above 10% of impacts. So the proxies that I used really didn't contribute to impacts and therefore probably are not really a problem in this analysis. Okay, so finally, I want to talk a little bit about my uncertainty analyses and what happened and what I had to do for this, because this unfortunately really ends up in the supplement and is not a huge part of the paper because it is kind of like a side project in itself. So originally I had wanted to run Monte Carlo analyses to get variability about the impacts for each of my commodities. If anyone has done this successfully with OpenLCA and EcoInvent, let's talk, because I ran into a lot of difficulties in terms of running these analyses. So instead, I thought, okay, I have the opportunity to potentially compare my results to other results using other databases, other software, and other impact assessment methods. So to do this, I only looked at the top 10 commodities that were served in the National School Lunch Program by weight. Like I said, that represented 65% of the food served by weight. So I looked at the top 10. This included things like apple, beef, carrot, milk, chicken, etc. Now, it would have been really great if I was able to look at the same database across different softwares and across different impact assessment methods, but unfortunately, I only had certain data available to me. So I ended up looking at these following databases: EcoInvent 3.6, which was the database that I used, and then World Food LCA database, and the following versions. And I looked at these within different softwares. So World Food LCA database was run in SEMA Pro. My analyses were run with EcoInvent and OpenLCA, but I also pulled data from EcoQuery, which is not necessarily like run in a software. It's just like the data that you can pull from EcoInvent online. So I added another variable and looked at different impact assessment methods. And then finally, I ranked these. So I'm going to describe this a little bit more. So for the rankings, I ran analyses with all these different methods for all 10 commodities. And within the 10 commodities, I ranked them. So for EcoInvent 3.6 with EcoQuery and ILCD, I ranked this compared to all the other ones that were this database, this software, and this impact assessment method. And then I compared the rankings within a particular food or commodity. And I looked at the standard deviation about these rankings and generally found consistency. You can see here for climate, apple came out as like 1, 2, or 3 in the rankings. It came out as 1, 2, or 3 for land. Beef across all of these different methods was always ranked 10th. So sorry, 1 being the lowest impacts and 10 being the highest impacts. And I did these rankings because these impact assessment methods have different units, and it's really hard to compare actual numbers with different units. So this ranking kind of took that difficulty away. And so I generally found consistency across the rankings. The only standout really was water consumption. It was less consistent than the other impact categories. So ultimately, this analysis really gave me confidence in using the EcoInvent data with OpenLCA because I was really able to explore using other databases and comparing them. Okay, so moving on to my discussion. So the real question after all of this work is really, so what can schools do to provide more sustainable lunches? What are their next steps? And how can these findings actually be contextualized? Because if you'll remember in the beginning, the purpose of this work was really to think about local interventions for communities so that we can start from the ground up making these transitions to more sustainable diets. So this work actually has implications for policy, funding, and school meal programming. Related to policy, I mentioned that there are standards for nutrition standards for these school lunches. So schools only receive federal funding if they follow certain calorie requirements, things like that. So if this research were to inform policy, it would inform minimum requirements for legumes, including peanuts and seafood, and recommend limits for beef and cheese. And in terms of other things outside of policy, like funding, there's other opportunities for schools for funding through legislation, but also nonprofits. There's a program called Farm to School in the US that provides funding for schools to try new menus, try new recipes, and source different types of foods. So this could be a great avenue for schools to start trying to adopt some of these changes, some of these new standards without being mandated to, where there's funding available. And in terms of funding, besides trying new menus, it's really important that this work is informed by behavioral interventions. You can't just serve children new food and expect them to consume it. You really have to consider potential unintended consequences. So this funding can also support effective behavior change interventions, which are definitely necessary to consider all of these other factors outside of just environmental impacts, but the costs, children, student acceptance, the nutritional quality of the lunches, etc. So that is all I have for you today. Thank you so much for listening. I just want to give a special thanks to my committee, who are co-authors on the paper that I sent out that I was discussing today, to my colleagues at, oh, sorry, Boston Public Schools. They provided all the photos. So all the photos today, pretty much except for the opening slide, were photos from Boston Public Schools' actual school lunches and some of my collaborators and my funding again. Thank you.
That was great. Thank you so much, Alex. It was really interesting. So we'll now open the questions. So if you have any questions, like type them, or you can actually raise your hand and you can unmute and ask directly. So I'll give you guys a few minutes. So a few questions of my own. So Alex, wondering, so schools in the US, are they responding to the research that you've conducted? And like, are there any schools interested in like working with you in terms of like collaborations to like kind of like do like any field tests or stuff?
Thank you for the question. So yes, I mentioned Boston Public Schools, a special thanks to them for the photos, but part of my work that I did in designing new menus was with Boston Public Schools. So yes, there particularly are a few schools that I've been working closely with, especially so Boston Public Schools and schools in DC that I had worked with in the past that are interested. But I have also been talking to, we have something called the Good Food Purchasing Program in the US. This is a nonprofit that helps schools to set higher standards for their lunches. So I've been speaking to them. They have a cohort of schools that have certain standards in place related to environmental impacts and sourcing, and getting this information out to those schools and getting these standards out to those schools has been really great. And besides that, I think legislation is very hard in the US. Changing the standards, that was a huge milestone that Michelle Obama worked on, and it's really challenging. But I've been talking to people at USDA and certain advocacy groups because I think there might be a pathway there as well, at least just sharing this information so people know that it's out there. So yes, there are some schools. It is not your average school, but I think as time moves on, this type of information will spread to them, especially as we start to consider other factors as well. So environmental impacts is one thing. It's super important, as I talked about in the very beginning, but schools also have to consider nutrition and if kids are going to eat the lunches and costs. So if those variables are incorporated as well, I think it can be like a win-win-win across different things for schools. So yeah, I think it's slow, but will happen and is happening.
Okay, that's great. We have a question from the audience. So they're saying that in their view, reducing meat in meals could lead to decreasing sources of protein. Like, have you had any ideas of substituting animal meats with vegan meats? Because you highlighted how like cheese was a really big cause of impacts. That's because in most vegetarian options, it's the substitute for meat. But like, what about for like people who don't eat meat or dairy? So like vegans or people with like lactose intolerance.
Yeah, that's a great question. So in the US, students are accustomed to having meat on menus. That's how it works. That's our culture. And there are some school districts that are starting to change or thinking about new options, but it's hard. Students aren't always accepting of it. Like New York City schools was going to do a once a week vegan day, but I believe that fell through. There was a lot of pushback in a lot of different ways because partly some of the meals weren't vegan even. And then just people love their meat in the US. So in terms of protein, there are nutrition standards for the National School Lunch Program. So those nutrition standards ensure that children are receiving all of the nutrients that they're going to be needing for 30% of their daily consumption. So in terms of removing meat from the menu, it wouldn't necessarily be changing the protein composition of the lunch. You would still supply something with adequate protein. Would I encourage schools to take on new vegan options, processed foods? Not necessarily. I think there's a lot of great ways that we can get less processed foods on menus that are vegan or vegetarian, related to nuts and seeds and legumes. I think there's a lot that we can encourage that just we're not even growing. Even whole grains can be really high in protein, so there's definitely a lot of options out there. I don't know that we need to look directly to Beyond Meat or Impossible Meat. I think there's a lot of other options out there. It's just about attuning children to these choices. So it's really hard to just present it to students and expect them to eat it. There's different ways to get students engaged by cooking and smelling and taste testing that really helps them to start explore what they like and don't like, and develop new or different habits.
Yeah, that's really interesting. So we have a comment from one of the members of the audience and saying that it'd be great to run a similar analysis in Brazil, and they will try to engage players there. So I was wondering from that, have you seen like similar studies conducted in other countries, and like how do your results compare to other countries?
Yeah, so almost exclusively in Europe. This work is any other work like this. So this work hadn't been done in the US, but really had been done, I think, in Italy, Spain, and the Netherlands. So really just Europe. I would be really excited for this work to be done in Brazil. I think there's a lot of excellent work happening in Brazil. If hopefully I didn't put my email on here, but I'm happy to connect or like share my email in the chat, Sonia. I have colleagues in Brazil that are like really engaged in this space. So maybe you're already working with them. But if you're interested in doing this work, I'd love to connect you. I think that'd be an excellent step. And in terms of comparing the work to European work, it was sometimes hard just because of different modeling methods. Also, a lot of the European work was really just greenhouse gas emissions. So I wanted this work to be a little bit broader and look at other impacts as well.
That's cool. And someone else has also asked, like, would you be open to collaborating on similar work in Africa?
Oh, wow, that's really exciting. Yeah, I mean, that that would be fantastic. My work right now is really focused on US food waste. I'm at EPA now, but I'd be interested in hearing ideas and what types of foods are served in Africa and what kind of needs different countries have in Africa related to like evaluating sustainability. Like maybe it's more resiliency with agriculture. It is about like changing children's diets.
Yeah, okay, great. We have someone that's raised their hand. So Fritz, do you want to unmute? I'm pretty sure you should be able to unmute.
There we go.
There we go, yes.
Yes, can you hear me?
Yes, we can.
Okay, great study. Congratulations. I enjoyed it and it looked like good results. Two comments. One is that a similar experience has been happening in France also, in terms of looking at school menus, in particular the experiment of one non-meat meal per week, which has resulted in a really major pushback from the livestock industry. And I'm just wondering whether you're seeing the same pushback from the agricultural sector in the US. My second question really is that for meat, it isn't just about the protein content in meals. The carbon footprint of meat is really big, particularly beef. So there are other reasons to avoid meat than adjusting the protein content. So there you are, the 2 points I'd like to make. So how is it in the US with the, what's the reception from the livestock industry for these sort of studies?
Thank you for these comments and questions. So in terms of my study, I have not gotten any backlash yet, but normally it's not good. Normally, and there have been some comments outside of the meat industry, just of the general public, of people really concerned about removing meat from school lunches. So I just want to express, I didn't show this in the presentation, but the amount of meat in school meals is actually very high. In a lot of circumstances, beef is served, if not once a week, twice or 3 times a week, or available every day. So there's really a substantial amount of meat on school lunch menus. So there's really not a concern that students won't be receiving the nutritional benefits of meat. Like the suggestions that I'm making are to reduce the frequency and the size. It's not eliminate. But I haven't personally received any feedback from the beef industry in the US, but it is a strong lobby and they definitely are not excited about this research. But I think there's potentially ways to at least connect this work to just agriculture in general. And I do that kind of at the discussion at the end of this paper, talking about how this work actually encourages the expansion of certain agricultural markets for things like whole grains or legumes and seeds. And those actually align with current policies that our US Department of Agriculture has already in order to protect the environment. So there could be some alignment in terms of market expansion, but just of different types of crops besides animal agriculture.
Just to follow up with an additional point, excuse me. There clearly is across various countries a quite different reaction from the livestock industry to these sort of studies. And I want to refer to the position of the Australian livestock industry, which is much more about looking for alternatives, looking to make the adjustments that are necessary to fit into the sustainability envelope, and including research on alternative stomach organisms which can provide the digestive power that is required without the generation of methane. So they're experimenting also and supporting research on adjusting the micro-intestinal flora, for example. So there's much more of an understanding there that something needs to be done eventually, and it's better to be part of the journey than to let someone else do it. And this is not the case of the French livestock industry, which is thou shalt eat more meat. And
I think that's a really great point. Oh, sorry, go ahead.
Well, to the point that the livestock industry in France is providing educational material to teachers in the schools about the benefits of eating more meat.
Oh, wow. So with regard to the point on the different microbes and just improving the way that meat is produced, this was actually an interesting point that I didn't get to dive in on more, but a good portion of, and I'm not sure, it's hard to lay down the exact percentage, but a good portion of the beef in schools is actually beef from dairy, from cold dairy, which has substantially different impacts based on the allocation methods you use. So there are these other alternatives to producing meat in different ways, and I think what's best is as these different processes develop over time and we have different impacts, we've determined the different impacts of all of these, we should apply this to our research and continue to make these estimates as these changes happen in the system.
Okay, great. So Eva has a question. She's wondering, for your analysis, did you do anything that was state by state? So do you have any results that compared to different states, or was it everything completely done on a national level?
Everything was done on a national level. It was all a nationally representative sample. I did have regional data, and in the beginning, I didn't get really interesting results. Maybe it's bad. I should have just presented the null results, that there really were no difference across regions or school types, things like that, in terms of the impacts of lunches. So that's why that information is not really presented in there. And I think that just has to do with the lunches served in the US they're following these standards laid out by the federal government, and they're just pretty consistent. There's just a few companies that supply the chicken nuggets and the hamburgers and the buns, and some schools do it differently, and there are some local companies, but it's pretty consistent what schools are serving across the US. So no major differences there.
Okay, it's really interesting, because I would have thought that a school lunch in Alaska would be really different to a school lunch in Florida.
That's a great point. I don't think Alaska was considered in our regions. I think it was just the continental US.
Okay.
I'd have to look back, no Hawaii and no territories. I think it was because I had the regions were New England, Midwest, West, South. I think that was it. So I don't know if Alaska was tied in somewhere. A lot of the data, because it was for the lunches served, it was collected by the federal government. So things are de-identified. So I wasn't able to like know exactly where the schools were, things like that.
Okay, cool. So have you had the opportunity of sharing your results with actual school children in the US so they can be more aware of like the impacts of their lunch and like the food that they eat?
I have not, and that would be an excellent step. And I think that step kind of comes with like sharing this information with the schools and those behavioral interventions. So in different schools, I think it's going to look like a different interventions, like with elementary schools versus high schools, the type of information you're sharing, why you're sharing that information, how you're sharing that information. So no, I have not, but when I was working with Boston Public Schools, I was in the schools at the time before my research had gone through. So I was talking to students a lot about if they liked their lunches and evaluating how much they liked lunches. So that was really fun and interesting because students would tell me all the time, no one's ever asked me if I like my lunch. I'm like, oh wow, yeah, we should probably be asking this to figure out if you're going to be eating it.
Yeah, definitely. So we have a question about the data granularity. So Catherine's wondering, like, did you have enough data granularity to compare environmental impacts of beef versus other types of meat? And can you determine what animal products are more environmentally friendly? So I think
Yes.
you did have a slide that kind of showed this a bit.
Yeah, thanks, Catherine. So all my results are in the context of what was served. So when more beef is served, they have higher impacts, or more chicken is served, whatever. But I did look at the differences between different meat products, especially when I was doing those sensitivity analyses and I was looking at the top 10 commodities. I ran it in all of these different data with these different databases and softwares. So yes, I do have that data. All of the inventory data is based either on like a global production system to represent something that would be relevant globally, or some of them are, my poultry might be US based. So yes, I had beef, chicken, pork, and I had lamb, and not that lamb is really served in the school lunch program. And then I had a few different types of seafood. And again, this is just the data that was available in EcoInvent. The only difference, the only addition I had besides the data in EcoInvent was data from Nathan Pelletier in Canada modeling layers. So I had egg data specifically from those studies, which are separate from EcoInvent.
Okay, cool. It's really good to know. So there's a comment and they're saying that Sodexo, I think I've pronounced that correctly, they did a project on how to communicate sustainable choices, and that might be useful for like when you want to engage school children with like the results of your work.
Thank you.
So we are actually on 7:30, but I see that someone is typing. So I'll give them some time to type. So I'm just going to ask a really quick question. So in your uncertainty analysis, just because I've never tried, I don't use OpenLC, I use Gabby, and I know that you can run Monte Carlo uncertainty analysis in Gabby, and it's quite tricky. So I was just wondering, like, had you managed to do that uncertainty analysis with the Monte Carlo method? Like, how different would you expect your results to be?
So I actually was able, so I ended up running analyses for about 100 different EcoInvent processes or activities, and I ran Monte Carlo for all of them, for all of the impact assessment methods that I looked at. And it essentially just created a range about my mean. But for some of them, for some reason, the range was not about the mean. And it was really strange. So the range that I got would be higher or lower than the actual result that I had pulled in just running the analysis straight through. And that was really, really strange. And I did not understand why that was happening. That is why I pivoted. Also, the simulations took days.
Yes, they
Like,
take a long time.
yeah, so I didn't do them on a cloud or a server. I just did them on my computer. Which was not a great idea, and that's partly why they took so long. So just really strange results, things that I wouldn't expect. And I have not spoken to anyone at OpenLCA or at EcoInvent, and it might have to do with just how the data quality matrices, or like the way that the range of possibilities for the simulation to choose from, honestly. But I'm not really sure, and I had to move away from that because it was really it was really hard.
Okay, yeah, fair enough. And we have one question. So this will be the final question. So due to the environmental impacts of beef, animal farming is discouraged. Do you think it will cause basically so like animals like cows are like basically just made for consuming meat? So do you think it'll have like any impact on them, on their population numbers or as a species? So like what will happen to all the cows and the chickens if we start to consume less meat?
Honestly, I think that this is kind of a question of power, who's in power, because that will determine what happens. I don't think that these animals will go extinct, and I don't think we'll stop eating them. I think culturally and in our heritage and in our makeup, like this is what we do, and maybe those will shift over time, but I don't think that they will become totally lost from our societies. I think we, as Fritz had said, might consider different practices for developing them, maybe like lab-based meat. We'll see where that heads. And if that is the direction in the future, maybe it will be smaller markets of what we're used to of like actual agriculture. So we'll see. I'm not sure.
Yeah, and also just to add on to that, I believe that in Sweden they are actually like selling a meat, a type of beef that has a much lower carbon footprint because it's fed, the cows are fed seaweed, so they like produce less methane through flatulence and stuff. So maybe we'll see more of those practices because it'd be interesting to see an LCA that compares like that kind of beef with like a regular beef.
Yeah.
Yeah. Cool. Yeah. Well, now it's gone past 7:30 UK time. So it's been such a wonderful presentation, Alex. It was really insightful and you presented so well. So I'd like to thank you on behalf of the network and all of our attendees. Like we really enjoyed your presentation.
Thank you so much for having me. I'm going to just go ahead and put my email in the chat. And I think that, Jasmine, you said you're going to send out the slides. So if anyone has questions, please feel free to reach out.
Okay. That's great.
Thank you again.
Okay, great. Thank you so much, Alex. And like everyone else, like have a good afternoon, evening, morning, wherever you're joining us from. Okay, so like, thank you, everyone. Thanks. Bye.
Bye.